I'm going to make a mallet out of this walnut offcut from a larger project, but there are a few cracks and areas I want to avoid. I start by marking those out, lining the piece up with my workbench, and setting a tape measure next to it for reference. After taking a picture of the piece, I can bring it into my design software to ensure I miss those spots. I have my design set here in the Vectric software with my work area sized out to the same size as the piece of walnut. I'm going to draw a rectangle around the perimeter here. That way we can see the edge of the workpiece through the image. So we'll drag our image on now and resize the image to match the size of the box. So we're using the measurement off the tape measure to do that, to ensure that we have everything set to the correct height. It's not going to line up perfectly square just due to distortion in the image, but it allows us to get us close enough so that I can position these pieces all around to avoid the areas I don't want to hit. And now I want to catch on the mallet handle. I would like to catch some of that sapwood in there. And that will be what we'll cut out. So we'll have everything ready to go. We'll catch some of that sapwood, and I'm utilizing the best grain here for the mallet head as well. And I'm also still getting nice vertical grain here on the handle, which is exactly what we want to see. I can use the rest of this for something else in the future, but if you're buying the plans for this, you can use this as a tutorial on how to size it out for the specific piece of wood that you have. So anyways, let's get this all cut. Sticking the walnut to the wasteboard with some X-Fasten double-sided tape. To cut the project, I'll use the Stepcraft Gen 3 D840 CNC machine with the Amana tool, 46350-K, 1/4 inch diameter Mortise compression bit. I'm going to add a ferrule and some brass rod to help with the assembly of the mallet. I need to first make a couple of test holes to ensure that they're cut to the right size. The smaller ferrule hole fit perfectly, but the brass rod hole was a bit too loose. I cut another test hole and got a fit with just a small amount of play, which I need as it will be going through 3 layers of material. Now that I have the right hole size, I applied it to the rest of the design and we can begin cutting. Compression bits have both an upcut and downcut portion of the bit, allowing you to get a clean top and bottom surface of the material. But you need to make sure that the first pass is below the upcut portion of the bit. The Mortise compression bit only has an 1/8 inch upcut portion, which allows me to take a shallower depth of cut per pass, cutting through this 1 inch thick walnut. The machine handled these cuts really well and had plenty of power and rigidity to accurately make these cuts through this thicker stock. I probably could have pushed this bit even a little bit harder to get it to cut a little bit faster, but we got these settings all dialed in at 100 inches per minute and it did a really nice job. I pulled the piece up and flipped it over to cut through the tabs using a multi-tool to pull off the skeleton. You can see that really nice clean bottom surface of the material that the compression bit left as well. Moving over to the saw stop router table, I use a 1/2 inch flush trim bit to flush up the tabs to the material. To soften the handle, I use the 49543 3/8 inch radius 4 flute roundover bit, using the micro jig gripper to help keep things safe while routing the handle. Most push blocks would want to rock on a thin piece like this, making things unsafe, but the gripper has a height adjustable foot, allowing me to keep things stable while moving the piece around the machine. I flip the handle over and will complete the profile on the back side. This bit leaves an extremely clean finish that won't require much sanding at all before applying finish. I love the feel of this handle, it's extremely comfortable to hold. Before I can get everything assembled, I need to cut the brass pieces to size. I stack 3 layers of material I need to go through, plus the thickness of the blade that I'm going to be using to cut. I transferred that measurement to the brass and inserted it into the offcut I used for testing the hole size. I clamped it to the workbench and used a vise to secure the brass while cutting. Using the fine Multimaster and a fine Starlock E-Cut Carbide Pro blade, I can begin cutting the brass, referencing the blade off of the wood to get a nice straight cut. The brass pieces will be used for alignment when gluing up, but will also look amazing on the mallet and also give it some extra heft. In total, I cut 3 of the 1/2 inch brass rod pieces that we'll use for assembling the mallet. I also needed to cut a piece of brass tube to use as the ferrule, and that will only be going through 1 layer of walnut on the handle, so we got that all cut as well. Each of the brass pieces was roughed up with some 120 grit sandpaper and cleaned with rubbing alcohol to give the glue something to hold on to a bit better. We can now begin assembly. First, I hammered the brass ferrule onto the end of the mallet handle. I spread the Type Bond 3 wood glue all over the face of the mallet and put the inside pieces and handle in place, repeating this process for the other outside face of the mallet. I used Starbond thick CA glue spread over the brass rods and twisted them in as I put them in to spread the glue evenly. This made alignment extremely easy and I was able to get everything in clamps without the mallet moving on me. I cleaned up the corners of the handle with a straw to remove as much of the squeeze out as possible. The bore clamps came off easy and none of the glue stuck to the face of the clamps. I cleaned off my belt on the oscillating spindle sander and began sanding the faces of the mallet nice and flush. Just a little bit of sanding left and some mineral spirits, and we'll get our first preview of what this thing's going to look like with finish on it. I always love seeing that first little bit of pop of color. It's really nice to see. All of the flat edges of the mallet head were rounded over using the Amana tool 49544 4-flute 1/8" radius roundover bit. The faces were final sanded with 220 grit, and the angled faces were eased over by hand. I really didn't like the scratch pattern left in the brass from the random orbit sander, so I went back with some 320 grit sandpaper and sanded in one direction to create a brushed look on the brass, careful to avoid the wood around it. I'm using boiled linseed oil as a finish. It's my go-to finish for anything like this, as it's easy to apply and recoat as the mallet sees use and wear. It also feels great in the hands and doesn't have that plasticky feel like film finishes tend to leave. I love seeing that hint of sapwood in the handle. It adds a bit of nice contrast. Let it soak in for about an hour and came back and wiped away any excess oil. The handle of the mallet was modeled after my hatchet handle that I use for light chopping but also use as a hammer. It's very comfortable to use in both directions. When you need to assemble wood joints or drive in a wooden dowel, a metal hammer will dent up the wood and leave marks all over the place, while a mallet like this allows you to drive in the wood without marring it up. I absolutely love the way that this project turned out, and the brass and walnut combination is absolutely one of my favorites. I would love to hear what you guys think about this mallet down in the comments below. The plans for this project and all of the tools used in this video are available on our website. Be sure to check them out there. Hopefully you enjoyed this one. Have a great day, everyone. Thank you guys so much for watching. If you love this type of content, be sure to subscribe right over here and click right over here for more great videos.